Hey guys, it's Miss A again, coming here to make a video for you over how to solve one-step equations. So if you're working on your choice board, this is going to go along with the D skills, D1, D2, D3, D4. You can see here that it does say equations and inequalities. This video is just going to go over equations. I will address inequalities in another video. This is just equations. So before we get started, I want to talk about a couple things. First of all, what an equation is. An equation is a mathematical sentence that uses an equal sign to indicate that the side to the left of the equal sign has the same value, as the side on the right of the equal sign. So both sides of an equation, on the left side of the equal and on the right side, both sides have to be equal to each other in order for them to be an equation. And the next thing we're going to talk about is inverse operations. These are actually what we're going to use to solve for the variable in a one-step equation. And these are operations that undo each other. Basically, inverse operations are just the opposite operations. So the opposite of adding is subtracting, and vice versa. And then the opposite of multiplying is dividing, and vice versa. So whatever the operation is given to you in the equation, if the equation is an addition problem, you're actually going to subtract to solve it. If it's multiplication, you're going to divide. You're always going to do the inverse operation or the opposite operation. Okay? So now we'll get into some examples. But before we get started on the actual examples, I want to talk about the integer rules that I made a video over last week, I believe. You need to remember these rules because they are going to come into play whenever you're solving one-step equations. So remember our rules for adding and subtracting are the same rules. We're looking for signs that are the same or signs that are different. If the signs are the same, what I mean by that is both numbers are positive or both numbers are negative. So when the signs are the same, you're going to add the numbers and then you keep the sign of the bigger digit. Remember, I'll say bigger digit because we're looking at the number without the positive or negative sign. We're just looking at the number, the digit itself that's bigger, regardless if it's negative or positive. And then the different signs means there's a positive and a negative number. Whenever you have different signs, you're going to subtract the numbers and then keep the sign of the bigger digit. Okay, so half of this rule is the exact same. The only difference is on the same sign you add, different signs you're going to subtract, but you always keep the sign of the bigger digit. And then when you're multiplying and dividing, we're going to use our handy dandy little triangle. You put a plus sign at the top, two negatives at the bottom, and you simply cover up what you have. So if you're multiplying or dividing two negatives, you cover up the two negatives, so your answer will be a positive. If you're multiplying and dividing a negative and a positive, cover up a negative, cover up a positive, so your answer will be a negative answer. Multiplying and dividing is really easy. All right, so we'll refer back to these as we're doing the problems. Hopefully you have these written down somewhere so you have them to refer to on your own. Okay, if not, take the time to pause the video and write these rules down because they are extremely helpful. All right, so here we go. Here is our first example. X plus 3 is equal to 10. So the reason I wrote it twice is because I want the original problem to be here at all times. I never want y'all to forget what the problem was. So we're going to always rewrite the problem a second time. So X plus 3 is equal to 10. The first thing I want to do, this is me personally, this is how I solve one-step equations, is the first thing I always do is, if I can think, is identify the variable. And when we identify it, we're going to put a box around it. So here, my variable, which again, variable in math means a letter that represents an unknown value. In this case, it's X. So I'm going to box my X. And then the next thing I always want to do is draw a line down my equal sign. So here's my equal right here. And I'm going to draw a line going straight down. Doesn't have to be very long, because we're not doing much here. So just draw a line through your equal. That's what I want you to do every single time. Box your variable, draw your line through your equal. Okay, so the reason we did the line is because this is a visual reminder that we need to do the same thing on both sides. We have to keep it balanced, okay? We want to keep everything equal. Kind of think of this as a seesaw. and you want both sides to be level. So you want to, or not seesaw, maybe more like a balance. You want both sides to be equal. So whatever you do to one side, you have to do the same exact thing to the other side. Okay. So when we have x plus 3, we box the variable. That's what we want to get all by itself. So right now, in order for the x to be alone, that plus 3 needs to go away. So remember, we're doing the inverse operation. So the inverse of plus 3 would be to minus 3. So we're going to minus 3 from the left side, and we're going to minus 3 from the right side. Remember, whatever we do to one side, we have to do the same exact thing to the other side. We're going to draw a line so we can solve. 3 minus 3 gets me 0, so I can literally just cross those out. They're gone, leaving me with x. My equal sign comes down here, and then now we have 10 minus 3. So 10 minus 3 gets me 7. So my answer is x equals 7. One thing it doesn't hurt to do is just to simply plug that value back into the original problem. So if I were to plug it in, x plus 3, so x is now 7. 7 plus 3 equals, I should get a value of 10. If I don't, then I know I did it wrong. 7 plus 3 equals 10, which is a true statement, so I know my work is correct. Okay, so that's not always a way you can double check your work. It's just plugging it back in and checking, making sure it is a true statement. All right, here's example number 2. X minus 4 is equal to negative 8. Sorry guys, it keeps focusing when I put my hand on it. X minus 4 equals negative 8. So again, we're going to start by rewriting the problem. And we're going to do our first 2 steps. We're going to box our variable, which again is x. And then we're going to draw our line through our equal sign. And then now we want to get that variable all by itself. So in order for the variable to be alone, the minus 4 needs to go away. The opposite or inverse of minusing 4 would be to add 4. And if we add 4 to one side, we have to add the same thing to the other side. Always keep it balanced. Keep them the same. Draw your line so we can solve. Negative 4 plus 4. If you remember your integer rules, these signs are different. That's a negative, that's a positive. So when they're different, we actually subtract. So all we really have to do here is just cross them off because 4 minus 4 is 0, leaving me with x. Bring down my equal sign, and then negative 8 plus 4. Again, these signs are different. When they're different, we subtract. 8 minus 4 is 4. Keep the sign of the bigger digit. 8's the bigger digit. It was negative, so my answer is negative 4. Don't forget those integer rules. Make sure you have those to refer to. Same sign you add, different sign subtract. All right, example number 3 is going to be negative 12 equals x plus 3. All right, and now the reason I gave you this one is because one thing that kind of sticks out to me here is the fact that my x is on the back end. It's on the right of my equal sign. Up here, my x was always on the left, and that's where you want it. That you always want your variable to be at the beginning or on the left side of the equal sign. So whenever it's on the right side, it's very easy fix. All you're going to do is literally flip everything. So I'm going to flip the x plus 3. Instead of in the back, I'm going to put it in the front. So x plus 3, then my equal sign, and then negative 12 goes to the back. I just like my variable being first. And then the same steps, we're going to box our variable, draw our line through our equal, and get that variable by itself. So right here, this 3 needs to go away. So our x is alone. The opposite or inverse of adding 3 would be to subtract 3 from both sides. Have to keep it even. Draw your line. 3 minus 3 is 0, so they cancel out. Because you don't need to put x plus 0. Plus 0 doesn't do anything. That's why we can just literally leave it off. So x equals, and then now we have negative 12 minus 3. So now we notice that both of these signs are the same. So if you remember your same sign rules, when the signs are the same, you add and then keep the sign of the bigger digit. So we're going to add these two numbers up. 12 plus 3 gets me 15. Keep the sign of the bigger digit. 12 is bigger. It was negative. So my answer is negative. All right. So just doing the inverse operation. What opposite of whatever it says. If it says to add, subtract. If it says to subtract, you add. All right. And then a couple more examples just for multiplying and dividing. I think these are a little bit easier. So the first one is 3x equals negative 15. So one thing we notice here is there's no symbol. There's no plus, minus, multiply, or divide. This x does not mean multiply. It is a variable. But because these two numbers are touching, 3 and x are touching, whenever these two things are touching, it means to multiply. So this is a multiplication problem. So 3 times x is equal to negative 15. So we're going to rewrite it. If it helps you, if it makes it a little bit easier to look at, maybe put a dot in between them. That's fine. The dot means multiplication as well. So 3 times x equals negative 15. So we're still going to do our first two steps of draw our line and box our variable. And again, we want the variable to be all alone. So in order for the x to be alone, the 3 needs to go away. They are attached by multiplication, because remember the dot, or when they touch, it means multiply. So the inverse of multiplication, the opposite, is to divide. So we're going to divide both sides. I'm going to use a fraction bar to represent division, because we're going to see that again in a little bit. Divide by this number because we want the x to be alone. The opposite of multiply is divide. So we're going to divide by 3, divide by 3. Now these cancel because 3 divided by 3 is 1. And you don't need to put 1 times anything, because when you multiply by 1, it doesn't change the value. So we don't have to put anything. We can just cross it off. X equals, and now we do negative 15 divide by 3. First of all, 15 divided by 3 is 5. And then don't forget your triangle. This is a negative. This is a positive. So we go here, negative and positive. So my answer is negative. So negative 5. Again, if we were to plug this in, negative 5. So 3 times negative 5 is negative 15, which is a true statement. So we know we got it correct. And then the last one, I'm going to try to squeeze here so I don't have to get a new piece of paper, is number 5. And this is x over a negative 2 equals a negative 12. Oopsie. X divided by negative 2 equals negative 12. So remember that fraction bar means division. Fraction bar means division. So I'm going to rewrite it. Sorry, kind of squished. Rewrite the problem. And we're still going to do our first two steps. We're going to box our variable, draw our line through our equal. So now we want the x to be alone, just like before. We want the x to be alone. The negative 2 needs to go away. This is not subtracting negative 2. This is dividing by negative 2. So the opposite of dividing by negative 2 would be to multiply. So we're going to multiply by negative 2 and multiply by negative 2. So these cancel, leaving you with x equals negative 12 times negative 2. So first of all, 12 times 2 is 24. And then negative and a negative, using your triangle, negative and negative make a positive. So x equals positive 24. If you were to plug it in, 24 divided by 2 is 12. Use your triangle, a positive and negative do in fact make a negative. All right, so there are my examples for solving one-step equations. Hopefully it's somewhat helpful. Remember, you're always doing the opposite, the inverse operation. All right, guys. Y'all take care. If y'all have any questions, let me know. Have a great day.